Hello, everyone. Well, I would like to share with you some learnings from a recent project. And as you can guess, this is about observability, although it's not about its most common use case, which is probably troubleshooting. This is more about how can you integrate it into your delivery process or release strategy when you are building a new feature. All right, so let me first walk you through our agenda today. First, we will review some basic concepts about observability. Then we will check out some examples just so that we are all on the same page. Then I will also share some tools that you can use. And later on, I will share some insights of our client's challenge. And finally, what was the strategy that we came up with to tackle this. Well, Monica already did a great introduction, but I already had my slides, so please bear with me. I'm a developer. I'm a senior consultant at Thoughtworks, and I'm based in Spain. I've been coding for over 10 years, something like that. And I think one of the things that keeps me going is learning new tech stacks. And it's maybe one of the things that I enjoy the most about working at Thoughtworks. But yeah, that's enough about me. So coming back to our main topic about observability. So I would just, out of curiosity, who has experience with observability, like using this practice? Okay, that's really great. Hopefully we can bump the numbers at the end of the sessions. So when you search about the term observability in the web, you get many definitions. So I also encourage you to do some research of your own, but one that I like comes from the OpenTelemetry website, and it goes like this. Observability is the ability to understand the internal state of a system by examining its outputs. And what I like about this definition is that it implies two things. In one hand, your system needs to emit data, right? But in the other, this data has to be high quality data, rich in context, so that you are able to understand what's going on in your system. And by this, I mean, how are your users interacting with your software? And how are your components interacting with each other so that in case of an error, you are able to recreate the scenario that actually led to the error and determine what the impact actually is. So I think there have been previous sessions of XConf also with the sessions about observability. So I also encourage you to take a look at those to have just a broader view of the benefits of adopting this in your team or your organization. So another question that often pops up when you're researching this topic is how it compares to monitoring. Well, in my opinion, they are different things, and in fact, they have like different goals. Monitoring refers to getting insights of an application, but these insights does not necessarily will give you a full understanding of what's going on in your system. Monitoring is useful to react to known errors. Let's say you are consuming data from an API which you know is error-prone. You would probably add a metric for that to monitor that state, right? But that's the thing. So you know this beforehand. You know that this is a situation that you want to monitor, right? So monitoring has this upper limit, and debugging will get more complex as your architecture or your domain grows. And in contrast, observability will aims to allow you to explore and drill down on your system state. So it's more useful to react to unknown situations or unknown errors. An observable system will emit data such as metrics, tracing information, and logs that will allow you to understand your user interactions. How are your users interacting with your system? What kind of user journeys are being triggered? And how this is generating interaction between your components as well, right? And in addition to that, you will have more flexibility to measure your system against your SLOs or business KPIs. Well, evolutionary architecture is another hot topic right now, I think. In fact, I think it's one of the last sessions of the day. And it basically encourages you to embrace change from the architecture level and adapt to evolving user expectations. So basically, the architecture is no longer this robust upfront design that will constrain your development. In fact, it will be shaped as you discover what your users actually need. And if you add microservices into the equation, then user journeys become now more complex, right? Now user requests will span across multiple components. And these components now will have a dependency on each other, which just basically increases complexity for change, because we want to be able to independently evolve our components, but without breaking any feature, right? So in my opinion, observable systems will be more successful at adopting this kind of architectures. All right, so let's check out some examples of how monitoring and observability look like. So let's imagine we have this simple monolith and a user makes a request, right? So this request fails and it will probably trigger an alert. And the engineer on call can then access the server and start pulling the data. And well, if the right metrics and the right logs were in the right place, then the engineer would probably be able to identify the bug, right? Now, if we switch over to the landscape of distributed services, let's imagine that we split this monolith into multiple microservices. Now, this same request would probably trigger alerts, right, into different services. And, well, now the engineer basically needs to be even more luckier to find the right information at the right place, right? And this is more tricky if these services are handled actually by different teams. But if that's not the case, and if the information is not there, then the alternative is to ship a new version of your systems, of your services, just with adding more logs or adding more metrics to identify what the issue actually was. And I guess some people might be familiar with this scenario. Whoops. Okay, but sorry, some slides missing. But if we add an observability platform into this same picture, our components would be connected to this observability platform that would be pulling all the data and correlating all the information for us, so that it's more easy for us to visualize this. And with all this information, we would be able to, for example, determine what kind of user it was, what kind of user journey was being triggered, how was the request flowing through the components. And we would be able to really understand the context that led to the error. And the engineer could, for example, foresee if the scheduled job C that it didn't fail that day would fail in the next execution, right? And take actions on that. All right, so what about tools? Well, fortunately, there are a lot of tools that you can try if you are starting to explore around observability. There are full-blown commercial tools like Datadog or New Relic, and there are open source ones like OpenTelemetry, Cygnus, and Grafana. And well, if you're starting to explore in this area, I would suggest you to try solutions, platforms that support the OpenTelemetry protocol, so that you are able to switch from one to the other without much hassle in your implementation. Right, so is it all about fixing errors? Well, that's the thing. When you read about observability, most of the arguments or benefits that you are presented gravitate around how you would become more efficient at fixing stuff, right? What you don't often read is how you can take advantage of this practice or these tools to introduce change with more confidence in your system. So let's take a look at a real-life example of how observability can help. So our team was working for a big European company that asked us for help to evolve one of their core services. And it was, in fact, a critical one, since it was part of the payment processing flow. And this service was consuming data from a Kafka topic that was going to be deprecated. And in order to support new features and to keep up with the business domain, this service needed to evolve, and a migration was needed. So as I mentioned, this was a critical service, and in case of any error during the migration, well, payment transactions would be impacted. Maybe one of your purchases would have failed. And so we also wanted to minimize downtime during the migration, right, to not impact user experience. Well, so I mentioned Kafka, and just in case you're not quite familiar with event processing systems like Kafka, I will just briefly share how this technology works. So this is a very high level and simplified representation of an event processing system. But typically what you do first is you create an event, right? An event type. And this basically just describes what data type and what kind of information the event will hold. Then you can start have publishers publishing data or messages into these event types. And the event processing system will retain this information for as long as you have configured. Then you can have consumers, and these consumers will ask the event processing system to start delivering messages to them from a particular event type. And the system will create a subscription that will relate a consumer to an event type. And these subscriptions will, in fact, be handled independently from one from the other. So one consumer can ask to only, for example, start receiving events, just the ones that arrive after the subscription was created, or maybe from a previous moment in time, as long as the retention time allows. And also consumers can, at any point, just drop the connection, and the system will remember what was the last delivered message, so that when the connection is restored, it will resume from where it stopped, right? So as I mentioned, this is a very high-level, simplified version of it. Underneath, there's a lot of much more things going on, but I think for our use case, this will suffice. Right, so before going into any solution design, we went into a discovery phase to check what was the existing architecture at the client side. And, well, we realized there were a lot of microservices in place. Some of them were event-driven. There was a mix, actually, of synchronous and asynchronous communication. It was a very interesting setup. And this company also was great in terms of engineering practices. They had automated builds and testing, tracing information, metrics and logs. Overall, observability was highly adopted there. So it was very nice. Right, so let me now present to you our core service right here in this red circle. And again, this is a high-level representation of the layouts of the components. And also, just for simplicity, I added this blue square here labeled services, which actually represents all of the things that were happening, tasks and processes and checks and validations up in the stream before our service actually kicked in. And so these services, after a new payment was created, would publish an event into this event bus. Our core service would consume this event and store the payment details that would later be served to other services, right? And, well, this was our target architecture. We basically just wanted to drop the connection to this legacy event bus and start consuming the same information from a new event type. Well, this might seem a simple migration, but in fact, it does bring some challenges. So our initial approach was to just introduce a new data store and start storing here all the payment details from events coming from the new event type. And our motivation for this was just to minimize downtimes. Right, but at some point, sooner than later, we realized that we would need to do some database migration to stick to a single data store. And until we were able to do this, we would also need to improve our endpoints that were serving the data so that they could handle two data stores. And, well, this just didn't feel right for us. So we decided to come up with a new plan. And sometimes, a simple solution is better. So we kind of ask ourselves, can we just swap the connection from one stream to the other, and that's it? We would maybe introduce a converter so that the remaining flow of our core service just would remain intact, right? Well, we realized that this was in fact possible. We would probably just need to play around with the timing of the subscriptions for each event and play around with the subscriptions and maybe introduce some metrics or something that would support us, our migration and make it observable, right? So then we had a session to brainstorm of the risks of this new approach. And our first concern was missing data, right? So we were going to consume information from these new events, but we wanted to be sure that they actually contained all the information that we expected. Then we were thinking about duplicity or lost events. As you may know, in these event-driven architectures, delays are inherent. So when a new payment was created, these services here would actually publish events right from into the bold streams, but we had no guarantee whether they would arrive at the same time or not. Probably not. So there was a chance that we would process both events coming from the both streams, or maybe losing events, right? So we wanted to minimize this. And finally, as I mentioned, we didn't want to impact the user experience. So whatever strategy we would come up, we wanted to also minimize downtime. All right, so there are actually many ways to address this risk, but let's take a look at how observability can help us. So I have basically just summarized our strategy, the steps that we did into this 3-phase strategy. The first thing we would do is we would do some data validation to address our missing data concern. We would then introduce some checks to avoid duplicity and add some metrics as well to make our system more observable during the migration. And finally, we would be able to move to phase 3, where we would do the actual switch of the connections to each stream, but in a way that we would guarantee that no events were lost and also minimizing downtime. So let's check out how data validation look like. So what we would do first, we would connect to the new event type in a read-only mode, meaning we would consume the data but not actually process it. We would actually just put metrics in the consumers from both sides of the streams to measure the amount of information that we were consuming, and this was really an easy step. We would just monitor this through the observability tools that we had in place. So once we were confident with the amount of data we were getting, we would proceed to validate the quality of the data. We wanted to be sure that all the information that we expected was there. And we would use this opportunity to test the converter that I mentioned earlier. So we would introduce a new temporary data store that would store the payment details. So after consuming an event from the new event type, we would convert this into our domain object and store this. If during the conversion any error should happen, we would print some logs and metrics as well to help us monitor the situation, and then we would be able to easily compare these mismatches at the database level, right? Without, of course, logging any sensitive information in the log stream. So then we would monitor this, and this step actually paid off really well for us because we discovered that we had overlooked a couple of cases, but thanks to the tracing information, we were able to determine what kind of user and payment method was being issued. So this was really easy to fix, but it was good to have all this information and all this context in place. So once we were confident about the data quality, we would move on to phase 2 to add some checks and metrics. So if you recall, in phase 2, we wanted to address duplicity and also make our service a little bit more observable for the migration. So in order to do this, after consuming an event, we would just publish a metric, and then we would validate if that message was already processed. And well, just the kind of tricky part here is that even if they were messages that were being generated by the same business event, meaning a new payment is being created, as they were coming from different streams or different event types, they had different physical IDs. So you need to find a logical ID that is remaining consistent across both streams. Let's say a transaction ID or a payment ID, right? And after you have this identifier, you can query your database and make sure that you have processed this event or not. If you have, you can just discard it. If you have, you can just discard it. And if not, you can process it and also publish a metric for this. So these are the metrics that will actually support our migration during phase 3. Right, so in phase 3, what we would actually do is just switch the connection from one stream to the other. And the first thing that we would do would be to pause the connection to the new event type, and we would just wait for events to start just coming, but piling up in the queue, right? And we would allow the same events to come through the legacy event type, and we would process them, right? And we would need to wait some more, right? Because we want to generate an overlap of the events. Whoa, sorry, it's going crazy. Yeah. Okay, 1 second. It's my sorry. It's a sneak preview of the following sessions. Okay, maybe I just stick to the. Going back. Right. Yeah. Okay, it's here. So wait. Yeah, it's fine. Yeah. So we wanted to basically, sorry about that. We wanted to basically generate this overlap that would in fact be what would allow us to guarantee that no events were lost during the migration while switching the connection. And after we have enough confidence, we could just swap the connection. And well, how long do you have to wait for this? Well, it kind of depends of how much traffic you have, how fast your services are at consuming these events. But for us, it was just basically a matter of minutes. Then we were able to actually enable the consumption from the new event type and just drop the connection to the legacy stream. So as you may figure out, what would happen when the first events arrive, they would be discarded, right? Because we added this duplicity check that would validate this logical identifier that we choose. So the first events would be discarded, right? But after our system picks up with a queue of events, the new events that start arriving would be consumed and stored from the new event type. So at this point, it's time to move to the monitoring part. So during the migration, obviously, what our process metrics would drop to 0 because we are discarding all of the events. And after our system picks up, this number should match, right? The amounts in blue, the line in blue represents the number of events that we are consuming, and the one in red represents that events that we are actually processing. So after our core service picks up with the events that were piling up, these numbers should match. And at this point, we then would move on to monitoring some business metrics, because we want to make sure that our system, the whole system, is still operating correctly, right? So we would monitor some business metrics like successful payments or something that is meaningful for your system. And another thing to keep an eye on is your dead letter queue, right? Which is the place where you drop all the events that you failed to process. And if after a while these numbers stay at a healthy level, then well, I guess we can consider the migration to be successful. So this is it for our example. I hope you have found it useful, and it will hopefully inspire you to keep using observability tools in your next challenges. So some thoughts I would like you to take away from these sessions are that observability is not only going to allow you to understand the internal state of your system, right? It can also support your delivery process or your release strategies. And in fact, when you start thinking on how to make your features more observable, when you start reflecting on how to make your features more observable, you end up doing this sort of observability-driven design that will not only allow you to introduce change with confidence, it will also prepare your teams, right, to react to unknown situations or unknown errors. And you will also find there an ally for adopting approaches, right, like evolutionary architecture, and ultimately embrace change with confidence. And yeah, that's it. Thank you.